Examples in calculus, the product rule. This is video 4. Example 3 uses the product rule in the form y-x equals gx times ddx of fx plus fx times ddx of gx. The following list of 7 short videos shows all videos, including this one, that involve the product rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Reminder: DDX, the differentiation operator. The symbol DDX is called the differentiation operator because it tells you to differentiate the function of x to its right. The following examples illustrate this important fact. 1. ddx of a function of x means differentiate the function of x inside the brackets with respect to x. 2. ddt of a function of t means differentiate the function of t inside the brackets with respect to t. 3. ddr of a function of r means differentiate the function of r inside the brackets with respect to r. In most textbooks, the function to the right of the differentiation operator is in brackets. A table of derivatives with examples that use the symbol ddx is in a video on my channel. A common error when using the symbol ddx. The symbol ddx must never be in an equation without a function of x to its right. This is illustrated in the following equation. ddx is followed by a function of x, correct. ddx is followed by a function of x, correct. ddx is not followed by a function of x, wrong, because ddx is not followed by a function of x. The product rule. Some equations have an equation number to their right, so the equation can be referenced later in this video. Let a function y be defined as y equals fx times gx. Then y is the product of the two separate functions, fx and gx. Now pre-multiply both sides of the above equation by d dx, giving d dx of y equals d dx of fx times gx. Then the product rule can be written in the form dy by dx equals gx times d dx of fx plus fx times d dx of gx. Call this equation equation 1. And since dy by dx equals y dash x, equation 1 can be written as y dash x equals gx times d dx of fx plus fx times d dx of gx. Call this equation equation 2. There are 4 separate functions on the right-hand side of the above equation. Gx, d dx of fx, fx, and d dx of gx, where d dx of fx is the derivative of fx and d dx of gx is the derivative of gx. Note that since d dx of fx equals f dash x and d dx of gx equals g dash x, the product rule above is just a different form of the product rule used in video 2 and video 3. Procedure. To obtain the derivative of a function that is the product of 2 separate functions, complete the following 4 steps. Step 1. Identify fx and gx on the right-hand side of the function you want to differentiate. Step 2. Substitute fx and gx into the right-hand side of the product rule to find y dash x. Step 3. Evaluate d dx of fx and d dx of gx, then substitute them into the right-hand side of the product rule obtained in step 2. Step 4. It is usually necessary to simplify the right-hand side of y dash x, and if y dash x can be simplified, then it should be simplified. Note that simplifying can involve expanding, collecting like terms, factoring, or all 3. An example using the product rule. Find the derivative of the function y equals 2e to the x into x minus 2 times x minus 3. Solution. Finding the derivative. Step 1. Identify fx and gx, comparing the right-hand side of the equation y equals 2e to the x into x minus 2 times x minus 3 with the right-hand side of the equation y equals fx times gx gives fx equal to 2e to the x and gx equal to x minus 2 times x minus 3. So after expanding, gx equals x squared because x times x is x squared, minus 3x because x times minus 3 is minus 3x, minus 2x because minus 2 times x is minus 2x, plus 6 because minus 2 times minus 3 is plus 6, and thus gx equals x squared. Collect like terms. Minus 3x minus 2x equals minus 5x. Minus 5x plus 6. So finally, fx equals 2e to the x and gx equals x squared minus 5x plus 6. Step 2. Substitute fx and gx into the right-hand side of the product rule. The product rule, equation 2, is displayed without commentary below. So for this example, y-x equals gx, which is x squared minus 5x plus 6, because gx equals x squared minus 5x plus 6, times d dx of fx, which is 2e to the x, because fx equals 2e to the x, plus fx, which is 2e to the x as before, times d dx of gx, which is x squared minus 5x plus 6 as before. Call this equation equation 3. Step 3. Evaluate d dx of fx and d dx of gx, then substitute them into equation 3 in step 2. Equation 3 in step 2 is displayed without commentary below. So for this example, y-x equals x squared minus 5x plus 6 times d dx of 2e to the x, which is 2e to the x plus 2e to the x times d dx of x squared, which is 2x, d dx of minus 5x, which is minus 5, d dx of plus 6, which is plus 0. Therefore, y dash x equals x squared minus 5x plus 6 times 2e to the x plus 2e to the x times 2x minus 5. Call this equation equation 4. Reminders displayed without commentary. To review the above reminders, you should pause this video now. Simplifying the derivative. Step 4. If the derivative can be simplified, then it should be simplified. From equation 4 on the previous screen, displayed without commentary, y dash x equals, which equals move the 2e to the x in front of the x squared minus 5x plus 6. 2e to the x into x squared minus 5x plus 6 plus 2e to the x into 2x minus 5 equals, expand the brackets. 2e to the x times x squared is 2x squared e to the x. 2e to the x times minus 5x is minus 10x e to the x. 2e to the x times plus 6 is plus 12e to the x. Plus 2e to the x times 2x is 4x e to the x. 2e to the x times minus 5 is minus 10e to the x. Equals. The objective is to arrange the terms in the next line so that their exponents of x descend from left to right, i.e. 2, 1, 0. The exponent of x in the brown term is 2, so put it first, equals 2x squared e to the x. The exponent of x in the two green terms is 1, so add them together and put the result next, collecting like terms. Minus 10x e to the x minus 10x e to the x plus 4x e to the x plus 4x e to the x equals minus 6x e to the x minus 6x e to the x. The exponent of x in the two orange terms is 0. So add them together and put the result last. Plus 12 e to the x plus 12 e to the x minus 10 e to the x minus 10 e to the x equals 2 e to the x plus 2 e to the x. Now the exponents of x in the three terms circled do descend from left to right. Exponents of x 2, 1, 0 equals, separate out 2 e to the x from each term. 2 e to the x times x squared minus 2 e to the x times 3x plus 2 e to the x times 1 equals 2 e to the x into x squared minus 3x plus 1. After factoring out 2 e to the x. Final statement. The derivative of the function y equals 2 e to the x into x minus 2 times x minus 3 is y dash x equals 2 e to the x into x squared minus 3x plus 1. Reminder: the exponents of x in the terms x squared minus 3x and 1 are 2, 1 and 0 respectively. So the exponents of x in the polynomial x squared minus 3x plus 1 do descend from left to right. When solving questions from your textbook similar to the example in this video, you should have the Step 1 and Step 2 screen displayed first, and then the Step 3 screen displayed next, so you can use them as templates to find the derivative. Then have this screen displayed so you can use it as a template to simplify the derivative. You should then find this topic simple and beautiful. Cheers. Do not forget to check your answers with the answers in the back of the textbook.